Hello and welcome to Physionic, where we learn the body from the macro to the micro. If that's something you think you'd be interested in, then consider subscribing. Today's examine is going to be a hot button issue, mainly because we are going to be discussing the differences between plant-based proteins and animal-based proteins for two different functions, one for anabolism and one for health. But we're going to be more focused on its anabolic properties. So we're going to be comparing a variety of different plant-based proteins compared to just a few of the popular animal-based proteins. So without further ado, let's go ahead and jump into this examine content. So this paper looks at protein types, be that plant-based, a variety of different plant-based or animal-based, and their impact on protein synthetic response. So let's look at the experimental methods before we jump into the results. So this study is not a study in itself, it's more of a review. So it looks at many different studies and pulls that information into one article or one paper. And then from there, they're able to determine, based a range of different studies, what is an accurate conclusion that we can make based off of the entire literature. So they do this using a variety of different methods. One, they look at just the total amount of amino acids, but they also use a particular scale. And that scale ranges from 0 to 1. And that scale is called a protein digestibility corrected amino acid score. And I'm definitely not going to say that from here on out. It's just going to be a PDCAAS. And that PDCAAS, PDCAS, that's what I'll call it. PDCAS is going to be used at least for the first few figures, and then from there they're also going to branch out and look at other areas and really do a comparison of a variety of different proteins. They also made sure that the conditions were isonitrogenous, meaning that the studies used the same level of protein, so total protein. If they compared a plant protein to animal-based protein, they had to be the same amount, which makes sense because if you don't, then, well, that really throws off the results completely and you'd have to back calculate based off of the results you got, and you don't really have to do that, so you might as well just go with the most true representation of what you're actually looking for between plant-based and animal-based. Another thing they did was they looked at synthetic markers, so they looked at, for example, leucine content, but they also looked at health markers, so just having the amounts of essential amino acids, and we're going to go into those as well. And finally, in terms of the actual studies that they looked at controlled trials, so they did look at kind of cause and effect style studies, and they also looked at longitudinal, so looking at over time, how does that cause and effect have an impact on our functional outcomes, so what is actually going to be applicable. So we're going to discuss briefly a few of those as well. So with that said, let's jump into the extremely exciting results. So the first table we're going to be looking at is table 2. I'm skipping table 1 mainly because it's just geographical data. So it tells you in Africa, in the United States, Asia, wherever it might be, they look at total energy consumption as well as amount of protein consumption, the distribution between plant-based and animal-based. That's not really what this channel is about, so I'm going to be skipping it, but of course you can check it out because the study will be linked for you to investigate yourself. So let's move on to table 2. Now table 2 is where they use that PDCAS, PDCAS, that I was talking about earlier, that takes into consideration the amino acid profile of the protein, but also the kinetics, meaning the kinetics of digestibility. So how readily is it digested and absorbed? So this marker, this system that they're using is going to measure proteins from 0 to 1.0, with 1.0 being the best outcome, so being the best protein. And there are a few different proteins that reach that 1.0 marker based off of this PEDCAS system. Now, the proteins with the best PEDCAS scores of 1.0 are milk proteins, eggs, so we've got casein, whey, things of that nature. And on the plant side, we have soy isolate. Now, I want to make the distinction between soy and soy isolate because you are isolating the soy protein from the soy plant in soy isolate. So that has a perfect 1.0 score if it's soy isolate, but you see a decrease in that score if it is just the soy plant. Now, the reason for that is probably because a lot of the other compounds that come with that soy plant reduce its digestibility. So that can have an impact on the score because the PEDCAS takes into account the kinetics of digestibility. I should also note that hydrolyzed proteins, so essentially proteins that are pre-cleaved or pre-broken down, tend to have a better PEDCAS score. So if you're looking at hydrolyzed casein or if you're looking at hydrolyzed whey protein, those tend to have higher PEDCAS scores as well. Now, a few notes that are not in this particular table but are written and discussed in the paper are that the plant-based proteins, when they're consumed, led to a greater excretion of amino acids, so which is really interesting, and we'll be touching on that later on when we go through the discussion. But essentially what they believe is that because of an unbalanced amino acid profile, meaning that you have higher levels of, or extremely high levels of maybe 1 or 2 amino acids and an incomplete profile in other amino acids, or such low levels in particular other amino acids, that leads to an excretion or a greater urea output through those amino acids. Not only that, it's possible that the body is using those high levels of amino acids for energy as opposed to using it for a protein synthetic response. Is that necessarily a bad thing? Well, in terms of anabolism, yes, but in terms of overall use as energy, well, not necessarily. And we'll touch on how we might be able to actually fix that issue later on. But it is true that with plant-based proteins, because of their unequal levels or their less favorable levels for mammals, or at least for humans, there is a greater excretion of amino acids. So now I'd like to look at table 3 and also look at figures 1, 2, and 3, mainly because those essentially represent the same thing, so in different ways of showing it. And here we see an establishment of the essential amino acids. So here we're looking at essential amino acids, but they're also going to be looking at leucine, and because leucine has such a high protein synthetic response. But the essential amino acids are really important because of just general health. Of course, we need that for anabolism because we need to have that for the growth of anything. We need all the amino acids. Now, just to make sure that we're on the same page, essential amino acids are amino acids that our body cannot produce or does not produce in ready enough amounts. There's something called a conditional amino acid. We're not going to be touching on that, but essential amino acids are things that your body needs to consume from the environment. So that would be from your food intake. Now, that is incredibly important for health, like I said, but it is also important for anabolism. But I'm going to be focusing on it more in terms of health, and I'm going to be looking at leucine content as more of an anabolic marker. Now, in terms of the highest levels of essential amino acids for the plant-based proteins, we have 2 primary standouts when it comes to essential amino acids and looking at plant-based proteins. We have spirulina and we have mycoproteins. So both of those supply a sufficient level, or high level, I should say, of essential amino acids, which is a great sign. Now, by comparison, however, if you look at animal-based proteins, a lot of different animal-based proteins tend to have a higher proportion or percentage of that protein being made up of essential amino acids. So whey, milk, casein, of course, comes from milk, eggs, beef, and other animal proteins all tend to have a higher percentage of their makeup is made up of these essential amino acids, which would be beneficial to health, but that doesn't necessarily mean that the plant-based proteins are bad for health by any means. It just means that for the best bang for your buck, you would need to consume animal proteins. Well, I shouldn't say the word need. You would want to consume animal-based proteins for the best bang for your buck. Now again, I'm going to be addressing some other factors to consider as we go along into the discussion section. Now, flipping the script to leucine, or more of a protein synthetic response, an anabolic response, but again, keep in mind that you need those essential amino acids for a complete profile to have that anabolism. I'm just looking at leucine as a marker because it is the primary marker when it comes to anabolism. We see that maize from plant-based proteins has the highest, really high proportion of that protein is made up of leucine, which is fantastic to see. It's only outclassed by whey protein when it comes to the animal proteins, which is great. But again, keep in mind that we're looking at proportions. We're not looking at absolute numbers. So it's still possible that you would need less whey protein compared to maize in terms of the consumption, because we're only looking at leucine. We're not necessarily looking at all the other amino acids. So maize or whey, it could be that way as well, no pun intended, that you have lower or extremely low levels in other amino acids that are crucial for that complete circle of the anabolic response. So if you don't have those other amino acids, then the high leucine content is fantastic, but that doesn't necessarily mean that you're going to get anabolism, mainly because you are deficient in particular other amino acids. Now with whey, that isn't as much of an issue because you do have a complete profile. It is considered a complete protein with high levels of essential amino acids, high levels of leucine, the highest levels of leucine, as well as, not that it matters quite as much, but having also non-essential amino acids. And now, as a quick point, talking about a longitudinal study that's discussed throughout this paper, they talk about the consumption of isonitrogenous and isocaloric, meaning the same levels of each, for both conditions of milk protein compared to soy protein. And what they found is that over 12 weeks, people who consumed a milk protein tended to gain more lean mass, so higher levels of anabolism and presumably lower levels of breakdown, or at least if you clamp breakdown at the same level, you still see higher levels of anabolism with the milk condition compared to the soy condition, which does feed into this narrative that plant-based proteins in some way, if that's on the back end, you get higher levels of excretion, you get higher levels of oxidation, meaning that you're using it more for energy as opposed to anabolism, or if it's just overall that the amino acid profile of plant-based proteins just doesn't quite compete or doesn't have the same leucine content. I mean, there could be a number of different reasons as to why that plant-based protein, something as powerful as soy, which is a great protein to consume in terms of anabolism, at least relative to other plant-based proteins, and even is somewhat comparable, depending on the conditions, to some animal-based proteins. You still see this favoring of anabolism for those milk-based proteins. All right, now that we've looked at the data, we've looked at the numbers, and we've broken down some of the results, I think it's incredibly important to discuss those results and what we can actually make out of it. Now, I realize that throughout this, I've essentially been trashing, well, not that I've really been outwardly trying to trash, but it seems that plant-based proteins are inferior to animal-based proteins. Pound for pound, if you want to look at it from like a fighter standpoint, 1v1, animal-based proteins are more anabolic than plant-based proteins. That is a non-negotiable fact. Okay, now that I've said that, I'd like to point out that that does not mean that if you use plant-based proteins that you are in an inferior situation. What do I mean by that? Well, there are a number of different points that we can look at this from. The first, and likely the most important and most powerful, is that you can simply eat more plant-based proteins, and those effects that you see, the differences in effects, because you have a ceiling in terms of the amount of anabolism that you can reach in a day, all you have to do is simply eat more of those plant-based proteins and you are supplying your body with sufficient amino acids. Certainly you're going to go through more of that urea and you're going to be excreting more of those amino acids, of those proteins that come from plant-based proteins, but you can also reach that ceiling just like an animal-based protein. It's just that you have to consume more of that total protein compared to an animal-based protein. But in terms of the functional effect, in terms of its overall impact on your body and muscle anabolism and really just anabolism in general, it's going to have no impact. You can just eat more and see the exact same results. The second point I want to make is something that they mentioned in the paper, is that you can also see that if you supplement with branched chain amino acids, and I realize that branched chain amino acids, BCAAs, have been trashed quite a bit in the scientific literature, but if you supplement with BCAAs plus consume a plant-based protein, that extra anabolism from those branched chains, of which leucine is one of them, you see this increase in protein synthetic response, and you see this decrease in the urea output, meaning that you are those proteins are not being used for oxidation, they're not being used for energy, but now they're being shuttled. They're being shuttled into a synthetic form, and they're going to be used for synthesis. And that's incredibly powerful. So if you were able to pair BCAAs, kind of an exogenous intake through a supplement of some sort, or just through another food, which I'll touch on in a second, with those plant-based proteins that you enjoy so much, then you can get the same response as you would from an animal-based proteins, especially if you tend to consume more of those proteins. If you are normally supposed to consume 180 grams of protein in general, if you were to maybe jump that up to 220 grams and take that away from your carbohydrates or take that away from your lipids, your fats, then that could ameliorate the difference between animal-based and plant-based. And finally, the final point that I wanted to make is this third point, and I alluded to it already. So not only can you supplement with BCAAs, but it might also be possible to just mix your proteins. So with an animal-based protein, you may not have to mix your proteins, but with a plant-based protein, there are so many different selections out there. You could easily mix 2 or 3 different proteins, and where one is deficient in a particular amino acid or a series of different amino acids, another plant-based protein could be very good at that, and you actually see that in those tables. You see the distribution, one might be low and another one might be high, so if you pair those together, suddenly you have a complete protein, and not only that, you might also have a more synthetic protein. So you can certainly mix and match those plant-based proteins and again ameliorate the difference and really close the gap and essentially delete the gap between animal and plant-based proteins. And the final point that I wanted to discuss is why there might be differences between plant-based and animal-based proteins. So with plant-based proteins, what you're finding is that it's not just the amino acid profile. So a lot of people focus just on that, but it's not just that. It's also just the fact that a plant-based protein is encased in particular molecules. So if you have something that's high in fiber, and that's true of any food in general, if you consume fiber with it, some of that protein or some of those foodstuff molecules get trapped within viscous fiber that's not broken down into its smaller components and is then excreted. So then you're lowering the absorption of those particular molecules, well, in this case, of those particular amino acids. So you have non-nutrition, non-nutritive substances within plant proteins that negate some of that absorption that you might get, especially even if there's a plant protein that has, let's say, more amino acids in a particular category than an animal-based protein. The difference is that the animal-based protein is almost completely absorbed, so you don't see some of that interaction in the intestinal lumen that's stopping some of that absorption. Is that going to have a massive impact? Probably not. When it comes down to it, it's the differences in those amino acid profiles. And there are certainly plant-based proteins that are going to be better at and just have higher levels of particular amino acids than those animal-based proteins. But overall, it just goes to show that an animal-based protein tends to be better in terms of anabolism and in terms of having that complete profile for health than plant-based proteins. However, I'm not saying that the other aspects of animal-based proteins, higher fat levels, higher caloric content, I'm not taking those into consideration, okay? I'm merely looking at the profile of amino acids, their digestibility and their absorption and their entrance into the cells. How much of each amino acid is there available and where is it going within the cell to lead to a more synthetic response? Okay. So with that said, I hope that this piece was informative for you, and I hope that I have the pleasure of speaking with you in the next one. Have a good one, guys. Bye.